Alright, hey fifth graders, again. Today, this is going to be the last video that we are going to be recording for this lesson. Hopefully it's really helpful because all we're doing for this video and this lesson is practicing on how to create hierarchies. Our two hierarchies are Venn diagrams and tree diagrams. Creating hierarchies classifying different polygons in two-dimensional figures based off of their attributes. Okay, meaning going from the most broad or the least amount of attributes to the most specific with the most amount of attributes. And we're just going to be using two hierarchy systems, like I said, tree diagrams, Venn diagrams. Okay, and we're actually going to complete 3 problems today, just practicing it. All right, so follow along with me, please. You guys actually do not have this one in your packet, okay? This is our warm-up problem. And I just like it because it's pretty simple. It's just asking us to draw a Venn diagram or a tree diagram to classify these shapes. I'm given 4 shapes. Okay, for this first one, I'm going to start with a Venn diagram. And we're going to just alternate between the two, okay? Alright, so remember, if I have a circle, I have a really broad, all-encompassing circle. Okay, it's not really a circle, more of an egg, but you get the point. Remember, my big circle is the most broad shape that I have in here. So let's look at the shapes that we have. Okay, we have parallelograms, rhombuses, quadrilaterals, and polygons. Now, if you remember from your reading and from previous videos, we know that polygons are absolutely the most general because all they have to be is two-dimensional. A two-dimensional figure with sides and angles. That's it. Okay, so every single shape we've introduced this week and last week have been polygons. Okay? So I know that my most general and my outermost circle is going to be polygons because all of the remaining shapes are polygons. Okay, I'll get the lights real quick, guys, so you can see a little bit better. Okay, then I look at my remaining 3. I know that parallelograms, rhombuses, and quadrilaterals. Well, what do they all have that are similar? What do they all have in common? If I look here, I notice that all of them have 4 sides. And what do we call a 4-sided shape? Any 4-sided shape? A quadrilateral. So my next most specific polygon would be quadrilaterals. So I create an additional circle because the remaining shapes are quadrilaterals. Okay? So I put quadrilaterals. I'm getting better at spelling these guys. And then I need to classify the last 2. Okay, which one has more attributes? Alright, well let's break them down. Let's look at parallelograms. I know that parallelogram is a polygon. I know that it is a quadrilateral because it has 4 sides. And I know that it has 2 sets of parallel lines. So, that's about it. It has no right angles, no anything else. Okay, so 3 attributes really. Now let's check out rhombus. Let's break down rhombus. Okay, it is a polygon. It has 4 sides. It's a quadrilateral. It has 2 sets of parallel lines, just like a parallelogram. But it also has one more attribute, which you probably know at home. It's kind of like a square, where it needs to have all 4 sides of equal length. 4 attributes, if we're counting polygon as an attribute. Okay? So parallelogram has 3, rhombus has 4. So what's the next most specific? It would be parallelogram, because it only has 3 attributes. I'm still struggling with parallelograms. Spelling those. Perfect. And then we know our last one and our most specific shape of these 4 would be a rhombus. Remember from our last video we focused mostly on tree diagram. So let's review what a Venn diagram and how we look at a Venn diagram. Remember, outermost circle encompasses all of the different shapes and is the most general or most broad of the two-dimensional figures. Polygons. Our innermost circle is the most specific. Okay, has the most attributes. Alright, least amount of attributes, most amount of attributes. Alright, cool, nice work. Okay, and like I said in the intro, we're just going to be continuing to classify different shapes, practicing it, using either a Venn diagram or a tree diagram. Okay guys, so I skipped forward a couple slides. And you actually have this page in your packet, so I'd love it if you guys could follow along with pencil and paper. We're going to be looking at page 603. Number 1 on page 603. Alright guys, and it's much the same as our warm-up problem. Okay? It says, draw a Venn diagram or a tree diagram to show the relationships among quadrilaterals, polygons, trapezoids, and hexagons. Okay? So once again, it gives us 4 shapes. Okay, then write a statement about the relationship between the quadrilaterals and trapezoids. Show your work. Okay, so the way we're going to show our work is through our Venn diagram or tree diagram. Now in our intro video, or the intro problem, I gave you guys a Venn diagram. This one, let's go with tree diagram. Okay? So, if you guys remember back to our first problem, you'll know that polygons right off the bat of the 4 shapes is the most general. Because, once again, you're going to get really bored of me saying this, but a polygon is any 2-dimensional figure, sides, angles. Okay? So every shape we've ever classified the last 2 weeks is a polygon. Okay, so top of my tree diagram is polygons. Okay? Very good. Now this is where it's going to kind of get tricky. Okay? Because we've talked in our videos and in your reading, we've talked about 3-sided figures, which is a subcategory, which basically means it's a triangle. And then we've spent most of our time actually talking about 4-sided figures, which is, we know, quadrilaterals. Now if I look in here, I see quadrilaterals, but I also see hexagons. Haven't spent much time on hexagons. And so I'm just going to give you the definition right now. A hexagon is any 5-sided figure. Okay? So do you see how we're categorizing different shapes? 3-sided, 4-sided, 5-sided, so on and so forth. We have triangles, we have quadrilaterals, and now we have hexagons. So they're actually in their own subcategory. Okay? So, quadrilaterals, we know, because we spent a ton of time on them, are going to branch off for polygons and be in its own subcategory. Quadrilaterals. Okay? But I can't place hexagons within the quadrilateral subcategory because it's not 4-sided. A hexagon, once again, 5-sided. So it's in its own subcategory, but it is a polygon. Okay? So if I look here, I have hexagons. Nice. Now, I'm left with one more. And our last video, yesterday, we were introduced to trapezoids, and they are 4-sided. And they actually have one more attribute, not just 4-sided. They need at least one set of parallel lines. Okay? So, trapezoids goes into the quadrilateral because it is 4-sided. But it goes under and is our most specific 2-dimensional figure here because it has one more additional attribute being one set of parallel sides. Okay? So, trapezoid right down here. Now, I think I remember reading something in the directions about making a statement. It says, then write a statement about the relationship between quadrilaterals and trapezoids. Show your work. If you're listening to my explanation, I think we just did that actually. It is under, the relationship is that they share 4 sides. They are both 4-sided. And that's really all you needed to explain. Because trapezoids have 4 sides. That's the relationship between quadrilaterals and trapezoids. It's really that simple actually. Okay? Fair enough. Alright, we're going to move on. We're going to do, I think we're going to do 2 more. This video might run a little bit longer than the other ones, but I think it's going to be helpful in the long run. Okay, in the directions here, now we're moving to page 604. Okay, so we do need to flip the page 604. I'll write it right up here, page 604. Okay, it says draw a Venn diagram or tree diagram to show the relationships among these polygons. Okay, so once again, it's asking us to choose one of each. Okay, so we just got done doing a tree diagram, so let's go with Venn diagram. Okay, so I know that I need a big circle. I think, yeah, we only got 3 shapes. I think I can fit it on here. Okay, remember, big circle meaning the broadest or most general of shapes. Okay, so we got polygon. It actually gives us a description. You don't have to memorize the descriptions here. It says quadrilateral, polygon with exactly 4 sides. That's it. Trapezoid, quadrilateral with exactly 1 pair of parallel sides. Okay? And then we got a parallelogram, a quadrilateral with 2 pairs of parallel sides. Interesting. Okay, so the most general, I think, is the easiest one right here to delineate is quadrilaterals. Okay? because both trapezoid and parallelogram, if you notice, are under quadrilateral and they are four-sided. So I know that my most broad is quadrilateral. Okay? And then, I'm left with trapezoid and parallelogram. Now, they do fit inside quadrilateral, but I don't think they fit within each other. What meaning, a trapezoid is not a parallelogram, and a parallelogram is not a trapezoid. They're in their own, once again, subcategories. Because in here, in a trapezoid, only one sets of parallel lines, and in a parallelogram, two sets of parallel lines. But they are both quadrilateral, so they both fit within the quadrilateral category. So if I go over here, I'll create a subcategory with trapezoid, and then I'll fit another subcategory with parallelogram. Right? Because of the different attributes. And that's it. Both quadrilaterals, but they're both in their own subcategories based off of their last attribute. Awesome. Okay. Hopefully that makes sense. Hopefully that was helpful. Next one. It actually gives us a Venn diagram. Okay, and we're back to triangles. Now remember, triangles, if we were to categorize different polygons, four-sided, three-sided, five-sided figures, triangle would be on its own subcategory because it's a three-sided figure. So every one of these different subcategories are going to be three-sided because they're all triangles. Okay? Just want to make sure that was clear. All right, so let's see. Look at the Venn diagram below, and then it says which statement is true. Interesting. Okay. It says, A, says an equilateral triangle is always an isosceles triangle. Well, let's see. If I look at the isosceles triangle category, I notice that equilateral triangle is always inside the fully inside the isosceles triangle. So could I say that an equilateral triangle is always an isosceles triangle? Yeah, I think I can. Let me get the lights real quick. Because the reason being, if you think about the attributes of the isosceles triangle, you know that two sides have to be the same length, right? Now let's think of the attributes of an equilateral triangle. Equilateral, it's even in the name, all three sides of equal length. Meaning, at all times, it's going to have at least two sides of equal length. So an equilateral triangle is always, every single time, an isosceles. At least an isosceles triangle. So, I actually don't really need to go far because that is the correct answer. But let's look through the rest of them to see why the rest are not true. Okay, let's see. Okay, an isosceles triangle is always an equilateral triangle. So, it's saying that it's actually the reverse of what we just talked about. But we know that an isosceles triangle cannot always be an equilateral triangle. Because sometimes in isosceles triangles, there's only two sides that are of equal length, not three. An equilateral triangle has that added attribute that makes equilateral triangles unique. So an isosceles triangle cannot always be an equilateral triangle. Can't. It's kind of like the rectangle square, I guess, dilemma that we run into, where a rectangle cannot always be a square, but a square can always be a rectangle. Okay? All right, let's look over here. Scalene and isosceles triangles share no attributes. Well, that's not true. Although a scalene is three-sided figure that